Eric, can you hear me? Good. Aki, can you hear me? Okay, good. So this is we're starting with this one, right? October. So we are doing I mensuration questions. I'll teach you from the questions like I was doing yesterday. It's good. We do together mensuration questions. Okay. And the first paper we do is October November 2024. October November 2024. This is the first one we are doing, and we go and we do paper 21. So paper 2, option 1. So we are going to do October November 2024. We'll do 6 papers. We'll do paper 2 1. October November 2024. We'll do paper 2 1, 2 2, 2 3. Paper 4 1, paper 4 2, and paper 4 3. Because mensuration comes in both papers. So we are starting with paper 2 1. That's the one we are doing. October November 2024, paper 2 1. Let's get to work. We go down, we keep looking for a mensuration question. Anytime where they'll give you a shape or even statements and ask for volume or area or surface area. And we add like that. So, this is similarity and congruency. It's not what we need right now. Here is one. They give us a sphere and they give us a cylinder. And okay, that's not a problem. What does the question say? That whatever the diagram shows is not important. The volume of the sphere is equal to the volume of the cylinder. So remember, I told you to say the last thing you want to do if you are a mathematician, never ignore sentences that have formulas. Never ever ignore it. So when they say volume of the sphere, we know formula for volume of a sphere. They gave you here 4/3 pi r cubed is equal, so you can say volume of sphere is equal to volume of the cylinder. So volume of cylinder. And these things have formulas. So now we should put formulas. We say volume of sphere 4/3 pi r cubed is equal to volume of a cylinder. We know volume of a cylinder. It is the area of the circle multiplied by the height. Okay? Area of cross section, which is the circle. Cross section means the simple shape you can see. It is the circle. Then you multiply by the length of circles, which is the height. Now, what you should know is when you're doing for different shapes, you should not put the same r radius. Make sure your radius is different. Here they put capital R for this one. So volume of a cylinder will be pi r squared h. For us, we'll say pi capital R squared h, because the small r has already been taken by sphere. Unless they tell us the two shapes have the same radius, make sure you have different radii. So you start by putting this. Okay? That's not even the question they asked. They want the curved surface area of the cylinder. But we'll come here after first dealing with this statement, because this statement was not given for nothing. So we all know that the mistake that people do in the whole world is they try to start here because it's the question that has been asked. People try to start by looking for curved surface area of cylinder. But hey, there's a statement you are jumping which has formulas. And that statement was not given for nothing. It helps with something. So let's go ahead and find volume and find the next thing. So we say 4/3 pi by the radius of the sphere. What is it? 6. So 4/3 pi by 6 cubed should give us pi. By the way, when you have pi on both sides, you can cancel it, okay? It doesn't affect anything, so you can cancel. So the next thing we write is 4 over 3 by 6 cubed will be equal to um, r squared by, because we don't know what the r is, by the height of this, which is 18 by 18. Now, already when we write this, we can see that obviously this was looking for us to find r, because that's the only thing we don't know. So we take 18 to the other side. If you want, you can first solve to say 4 times 16 cubed divided by 3 will be equal to 18r squared. Then you take 18 to the other side, it will go and divide. And since 18 is going to divide, it will go and join 3 there. So you now have 4 times 16 cubed over 3 times 18 should give us r squared. Okay? What is the answer going to be here? When you're punching in the calculator, always put brackets on the numerator. Okay? So, and you also put brackets in the denominator if there's more than one thing. So can you tell me what you get here? By the way, to then get r, you'd say r would be the square root of everything here. But first, let's find it. Open bracket 4 times 16 cubed divided by open bracket 3 by 18. What do you get? Kingsley, tell me what you get first. Everybody, make sure you have your calculator. Sometimes I'll ask you to punch. I can ask whoever. Kingsley, what do you get here? Four by 16 cubed. Oh, 303.407. Okay. 303.407. Right. This is r squared. Now to get r, you say the square root of that. 303.407. The square root gives you r. What is that? What's the square root of this? What is the answer? Yes, Wandipa? Okay. Mm-hmm. Did you put the brackets? Are you putting the brackets? Did you say did did you put the brackets and say open bracket 4 times 16 cubed? Okay, good. Right. So can you now get us the square root of that? What do you get? Should get something like 17.4 or 17.42 centimeters as your r. Okay, rounding off 17.42. So now you're not done. You now have the radius of the cylinder. Now they want you to find the curved surface area. Right. So students, I want you to be talking with me, okay? We need to be talking. So make sure if I call your name and I ask you to punch, you punch it with me. Are we agreeing? Everybody? Make sure if I call your name and I ask you to punch, you punch, okay? I don't want spectators. I want us to move together. Good. No spectators in here. Now we are going to find the curved surface area of the cylinder. Right. Here's the thing. Cylinder, when you open it, right? This is a cylinder like this. Okay? Like that. If you open it up this way, you pull here, then you pull here, you are going to get a rectangle. Right. So when we are getting what we call the surface area, it means the area exposed. The cylinder was round like this when we put it together, but here we have opened it. You get a rectangle, and you get a circle on top and the circle at the bottom. This is what a cylinder becomes when you open it up. Okay? So when you want to get the total surface area of a cylinder, you get the circle on the top plus the circle on the bottom plus this rectangle. So to get the curved, this is what they were calling the curved surface area. This one, when you open it, it's a rectangle. Now, this rectangle, this will be the height from this, the height of the cylinder. And then this one, these are the length here. Let me put it in green or in blue. These are the length which I've put in blue, because to get the area, we need to get area of that rectangle. To get the curved surface area, we need to get area of that rectangle. And area of that rectangle is from the circumference, the distance right round, which is 2 pi r. The distance right round the circle when you open it is so it's 2 pi r. So students, the area of the curved surface area is length 2 pi r times width h. So it is 2 pi r h, which for us is the capital R. 2 pi big R h. Because we know that the length is 2 pi r, then you have the height as your width. So when you want area, it's length times width, which is 2 pi r times height. So it's 2 pi r h, the area of the curved surface on the cylinder. What do you get? It's 2 pi by your r, 17.42, by your h, which we already have as 18. Right, somebody, can you tell me what you get? Here I want you to say 17.418, okay? You open it a bit because you are continuing with the calculation. What do you get here? 2 pi, you open bracket, 17.418, you open bracket, you say 18 again. What are you going to get? Anita, what is the answer for this one? Okay. Point what? Well done. 0.99. So it's like you round it off to 1970 centimeters squared. 1970. So look, students, we only went to their question after we used this relationship. This is a key relationship. We were not supposed to ignore this because they said something we should attract our attention. If you do that, of course you'll be fine. Will I worry about you? No. Why would I? Why would I? I won't. I won't worry about you because I know that you'll be fine. Right. Let's go for the next one. Let's go for the next one. Let's go. Let's keep going. Next paper. So, is everybody satisfied with our paper 4-1 from October, November 2024? Paper 2-1. Are we all happy? Is there a part B? No, there is no part B. Are we all happy? Right. Should I do mensuration and trig or mensuration only? Okay, let me do mensuration only so I don't confuse. Is everybody happy here? Okay. Let's go to paper 4-2 now. Let's go to paper 4-2 now. Okay. Let's go to paper 4-2 now. Let's see what paper 4-2 has for us. No, 2-2. Paper 2-2 rather. October, November 2024. Paper 2-2 now. Right. Paper 2-2. October, November 2024. Let's look for mensuration. Let's see what we're supposed to do. Calculate the area of the circle. Here is the question. Right. Let's see what they wanted us to do. Let's do it together as fast as we can. Blah, blah, blah. These points lie on a circle. ABCD is a square with area 72. Okay, so how can we ignore this? The points lie on a circle, and they said it is a square with this area, right? Calculate the area, give your answer as a multiple of pi. So they want us to find, let me write it, the area of a circle, and they told us that this square has area 72. So area of the square will be equal to side times side. Okay? And they said 72 is equal to side squared. Side times side, if we can say that. 72 is side times side, which is side squared. Which means if we want to get one side, we would say square root of 72 should give us one side. What is the answer there? If you say square root of 72, what do you get? Students, if you say square root of 72, what are you going to get? Somebody? Exactly 8.48, or it has more decimals, or what? Is it going to be exactly 8? Okay, it was what? 8.48 what? Okay, 8.4852. We can leave it like this is a little bit better, centimeters. So this is each of this. So you now know that each of your sides are 8.48, right? Hello? So you now know that each of your sides are here, are 8.48. Now, here we are now coming. So what we want to have now, they want us to find the area of the circle. Calculate the area of a circle. Now, how am I going to get area of the circle? For me to find area of a circle, I would need to have a radius of the circle, which is this r. Or it's the same as this one. This is r. I would need to have this r here. This one as well. This is the radius. If I can find this radius, then we know that area is equal to pi r squared. Is it true? Hello? Is it true? If you don't want to put this as 8.58, you can put it as root 72. Since you may want to use it in calculation. So let's say that this is root 72. That's what we know so far. So far what we know is that here we have root 72, and root 72, right? Now, here, the next thing which we're going to have is we are going to look at this triangle here. This triangle here. And we are going to say this is root 72. Here we have an angle Here we have an angle theta. Here we have another angle theta. Here we have it. So this is an isosceles triangle. And we have root 72 as one side. Now, let me say something here, which is important. When you have an isosceles triangle, okay? When you're going to have your isosceles triangle, you can know that the base angles of the isosceles triangles are going to be equal. So if the base angles of my isosceles triangles are going to be equal, if I choose an angle here, these two sides will have the same angle. These are the two sides. That's one thing. So if I say this is going to be, let's say I make this 90 degrees, then I'll say 90 plus theta will give me 180. So I'll be saying 90 degrees plus theta will give me 180. Then I can find this theta here, or I can say there's a trick which we do in trig. Here's how it works. Let's say I have, look at how we do it. Let's say I have this theta and I have this r. If I want to come from this r and go to get this x, I will be saying to come down here. It's a Sokotoa thing, okay? It's a trick from Sokotoa. You'd be saying to get x, you get r times cos theta. And then to get y, which is this one, you say r times sine theta. To get something which is up like this, if you have a slanted one. Can you see it? So if I want to get, I have this root 72. I can cos theta to get root 72 to get this one side. It's like a slanted one. Look at it. It's like this. Okay? And this is your biggest side, which is your root 72. Let's just say that. Okay. So if I want to get this one, I would say root 72 cos theta, this angle. And then if I want to get this one, I would say root 72 sine theta. Now, since this side and this side are the same, that means that there is only one angle which can help me find radius and radius from this one. It's 45 degrees. This is a bit of a trick that I would need you to know. Is that, let me teach you right now so that you can use it forever. Listen to this trick, okay? It is that if I want to find r and I have this 72, so I have 72, and it's at the base angles of the isosceles triangle. It's at the bottom of this isosceles triangle. Isosceles triangle is like this. A triangle with two equal sides. We call it an isosceles triangle. Now, where your two equal sides meet the third side, we call them base angles. Where the two equal sides, this side and this side, where they meet the third one, the angle there, this angle theta is called base angle. And we say the base angles are equal. Base angles of an isosceles triangle. Okay. If these base angles are equal, and you have this length here, we have this length root 72 here. Now, and it is here we have a square, and we are cutting it off like this. What we should know is that the angle that can take you from root 72 and make r again is 45 degrees. Also because we have a square, it's also because it is subtended on a square. So we'll be saying, here's what we are going to say. To come from 72 to go to R, you say R is equal to, remember, R is smaller. This R and this R. Remember, it is smaller. So I'll say, to get R, it will be root 72 sine 45 degrees, or root 72 cos 45 degrees. This would be a 45 here degree angle coming from your square. This square, we're going to both sides of a square. This has to be 90, which means this is 45, this is 45 degrees. So you would say, for us to get R, you start with the biggest side, which is the third side, this one, the base, root 72. And then to get R, you can say cos 45 or sine 45. So root 72 sine 45. Now, since we have the, so that is why we needed to find this root 72. We can now use it. So we can say R is equal to, which is going to be root 72. What is root 72 times sine 45? What do you get as your R? 6. You see, you get a nice, if you see yourself getting these type of nice answers, then you're probably on the right path. Area now will be pi r squared, which is pi times 6 squared for area. What do you get as your area? Pi times 6 squared. $36 pi. Yes, if you want, you can say 36 pi, because they want it in terms of pi. So area is 36 pi. 36 pi centimeters squared. Well done. Now, we scroll down and look for any other question of mensuration in the paper. Right. There we have it. We are doing another one. Right. These ones are ones that can repeat. So you should listen more attentively on these ones. This is a good one. Here we have a cylinder and a hemisphere. Everybody knows what a hemisphere is, right? Half of a sphere. Can you see? The head is half of a sphere. Can you see this thing? It's a hemisphere, which is half of a sphere. So anything you want about it, you'll be saying for the sphere, then you divide by 2. Now, let's read the question. When we say read, we are skimming through. We are looking for anything that we can use. Okay. Both have the same radius, blah, blah, blah. Calculate the volume of the solid. Okay. So if they want volume of the solid, we'll say here, the volume of this solid is volume of the cylinder, which is number 1. Yes, Aki, I see your hand is up. Area, when we're getting area, pi r squared. Okay, no problem. For area of a circle, make sure, right? So now we go down here. We say area of, they said volume. Now, volume of this solid. So we know that when we do these weird things, we have to do them piece by piece. You can't combine. So it's volume of the cylinder plus volume of the hemisphere, which is going to be volume of a cylinder. You should know the formula, okay? Pi r squared h, okay? It's the circle, area of the circle, pi r squared times the height, which is pi r squared h, plus volume of a hemisphere. It's 4/3 pi r cubed. O divided by 2. Volume of a sphere divided by 2, because we are doing volume of a hemisphere. Good. Which is the same as what? This is pi. And the only reason we used, remember, be careful. You only use the same r for different shapes if they tell you they have the same radius. So here they have both radius 4.3. So that's fine. So it is pi r squared h plus, here when you divide by 2, these 2 will multiply with this 3 in the denominator. So it'd be 4 over 6 pi r cubed. So now you're going to say the volume of the solid is going to be equal to pi times r, 4.3 squared, times the height. Okay, this is now just about punching, 11.9, plus 4 over 6, open bracket, pi by r cubed, which is, the r is 4.3. So by 4.3 all cubed. You must remember the formulas. That's so important to remember the formulas, and you can then use them on and on and on. So there we go. Now, what is the thing going to be? What do we now do? What do we get as our solution? Can somebody please punch? Okay. Remember to put the fraction in brackets. Can you punch it like this and tell me what answer you get? Sarah, what answer do you get here? You got 80? Okay. So, did you put all the brackets the way we did? Okay. Is this the same answer everybody got? I'm punching with you. 4.3. Okay. You got what? Punch it again. Did you put 4 over 3 cubed? Sarah? Sarah, did you put 4 over 3 cubed? What answer are you getting? Pakiso. Are you getting the same answer? Yes, good. That's the same one I got. That's 800. That's the answer. 857.7. Sarah, did you put 4.3 cubed? Yeah. That's what I thought. Okay, so if you put, you should get 857.77 cubic centimeters. There we go. Okay, just by putting, so anyway, people, here you are seeing that we do the shapes, we add the shapes, we We get the volume of the first one, then we get the volume of the second one, which is a hemisphere, which, remember, you just do sphere over 2. There is no special formula for hemisphere. When you want to get hemisphere, you do the sphere, then you divide it by 2, you will get the hemisphere. Good, great job. Then now you come here to surface area. Okay, so let me just mention this today since you're doing. So we should know when we are doing volumes of all the things, or should we do surface area on its own thing? Let's first master volume questions, right? Then when we're confident about, when we know volume questions, we do surface area, because I don't want to mix up the formulas. Let's do paper 2-3 now. Volume and area, that's what we're doing. We'll do surface area as the last thing. Good. Now, volume, here's the question. Paper 2-3 now. We are doing paper 2-3. We can't find the mensuration. All right, let's do the paper 4s, then we're done. Just a few. We do paper 4-1. October, November 2024 again. The paper 4s now, just want to see what they bring. Nothing about mensuration yet. Area of volume, nothing yet. Did they say area? Right. Calculate the cost of part of the field, triangle ACD. So triangle ACD is sold for 41,500. Calculate the cost of 1 hectare. Right. Let's say this. What we're supposed to find is the area. What we're supposed to find is the area. Then we will now do area per. We will now see how we can do cost per hectare. We should know how many hectares were in this, because they want cost of 1 hectare. In other words, they want cost per hectare. They want cost per hectare. Well, obviously, if you want cost per hectare, we should know the total hectares. We come here. They say the field is called ACD. So we go to ACD. Now, class, we need to find area of this triangle here. How many types of triangles do we meet when we are doing area of triangles? 3 types. We have the first type of triangle, which is a right-angled triangle, where you have the base and the height. So area is base times height over 2. Then you have, this is one with a right angle, right? So this one is triangle number 1. It has a right angle, it's just base times height over 2. Triangle number 2, you'll be given the base and you'll be given the height, and they'll do it like this, okay? And to get area for this one is also base times height over 2. This is the second type of triangle. Yes, there is no right angle. It doesn't have a right angle, but it has base and it has height. So we can use it. Then the third type is this one now, where you are given the angle theta, You are given this side A and you're given this side B. There are only these three situations. You don't have any other situation. These are the only three. For this one, you say area is equal to A times B times sine theta, all divided by 2. This is the one. And if you go to the top, you see them say half A, B, sine theta, or whatever. But this is the one. A times B times sine theta, all over 2. Which is this one? It's this situation we have. This is like our A. This is like our B. This is our theta, which we put. So we're going to say, okay, for this triangle ACD, you say area of ACD is equal to the area is equal to, what is your A? It's this side here, 420 meters. So you say it's 420 meters. If you want to put it in symbols, you say this is opposite capital C, so it's called side small c. This one is opposite capital A, so it's called sine small a. So if you want, you can say it is A times C times sine theta, which you can say sine D, okay, because the angle is at big D. Okay, so you can say A times C times sine D all over 2. In other words, you know the formula. AB sine theta over 2. Well done. So this is going to be, what is your small a? This side, 830 meters. If you don't want to do this, it's still fine. You can just say 830 meters times, okay, the other side, which is 420 meters, times sine of the angle. What is the angle? 106. So times sine 106 degrees all over 2. Then you get the area. What is that? Open brackets. Remember to put everything in the numerator in brackets like this. Open bracket, then you start opening and closing those brackets, and you close the last one. Then say divided by 2. Tell me what you get. Tobo, what do you get for this one? Punch quickly, Tobo, punch quickly. Ooh, sorry for that. Are you able to see it? Are you able to see the screen right now? Okay. Sorry for that. I can tell that your network is bad today because your voice is glitching. But yes, tell me, try to punch this and tell me what answer you get, Tobo. Did you punch? Hope. Did you get an answer? Hope. What is the answer? In square meters, it should be quite big. You should get a big answer. So we can change to hectares. What is it? Okay. 500 and what? 547.9. Okay. So this is square meters. Now we need to change it to hectares. So you can say area of ACD will be equal to 167.5 no 167,547.9 divided by 10,000. Okay? And this is now hectares because 1 hectare is 10,000. So we divide it by 10,000 so that we get hectares. What do you now have in terms of hectares? What do you now have in terms of hectares? So let me tell you how you convert to hectares, because somebody, this is the exchange rate. It's a trick you must know for exchange rate. So remember, we have these as square meters. We want to change it to hectares. So we have it as square meters. The first thing we do, we divide it by square meters. Then we multiply by hectares, which is times 1 hectare. It's here, hectare. We multiply by hectare. So you can now get, what is your area, ACD, in hectares? What is 167,547.9 divided by 10,000? It is, move the comma 4 times. Isn't there 4 zeros? You move the comma 4 times. 1, 2, 3, 4. It is 16.75479 hectares. Now, remember, you want the cost per hectare, which means the cost of 1 hectare, which means, okay, cost of 1 hectare is like the cost per hectare, which means you are dividing by hectares. So I want you to say 41,500 divided by 16.75479. What do you get? So that we get the dollars per hectare. What is the answer here? You've done a lot of work. Just tell us what the cost of 1 hectare. Remember, cost of 1 hectare is like saying cost per hectare. What should you get? What are you going to get? Okay. 2,476.90. You remember, for currency, all currencies, you put only 2 numbers after the comma and you stop. So this is your answer. $2,476.90. This is your final solution. Are we together? So this was about you finding the area of the triangle, which we have done. So don't let me down. Area of triangle. Just go in steps, okay? Part of the field, the triangle, is sold. Once you see them talk about the costs and whatever, I'm telling you right now, you need areas and volumes to find costs and things like that. Okay, so this is the last one that I was doing for you. Um, Let me see if we have another mensuration question, because this is just one. Work out the volume of the cuboid. Volume is length times width times height, which is 10 times 8 times 17. What do you get? What do you get? 1,360. Okay. 1,360. Good. That's fine. Now, okay. I didn't want to do surface area. I don't want to do surface area. But for cuboid, it's and things like a cuboid and stuff, it's unacceptable because surface area just means area of all the surfaces when you add. So you've got length by width, which means this one at the bottom here. Okay, you get its area by saying length times width. And there are two of them. It's bottom and top, unless they tell you the top is open. So it's 2 of length times width. Then you have length by height, which is the front face here. It's length and height. Then you have width by height, which is the side face, and it's there on this side and on that side. So you have surface area. So total surface area is 2 of length and width plus 2 of length by height, which is front and the back, plus 2 of width by height, which is the sides. So this is going to be 2 of, what is the length? 10 times what's the width? 8 plus 2 of, what is the length? 10 times what's the height? 17 plus 2 of, what is the width? 8 times the height? 17. You get your nice answers for the total surface area of your cuboid, and you move on. What is this? Can you punch this, someone? Seven, 77. Okay, yes, 772. This is centimeters squared. I agree with you. 772 centimeters squared. And this is your final solution for here. Right. Good. There's nothing else on this. Length of the rod PQ. We'll come back to this. We were doing it together last time. Well, anyway, a rectangle has this area. This is a mensuration question. By forming and solving an equation, show that x is whatever. Well, the rectangle has area. So this is not abracadabra. Area of rectangle is length times width. The area, which is, they told us 190 is the area. It is equal to, what is the length? 2x plus 3 multiplying, what is the width? X plus 1. Okay. So you just solve this one, you get x 8.1. Because it will be quadratic. And you solve it. We're not going. Work up the perimeter. So once you have x, you can put it in here to find this length. Put it in here to find this length. And then you now add. So there will be x plus 1, another one here. 2x plus 3, another one here. So you just add them. And you have the total distance right round. So the most, let's just say you did not get 8.5. When you did your own thing, you failed to get 8.5. The fact that they said show it means in part B you are using x 8.5. This is the correct answer. If you can't get it, then use it in part B. So you're going to say length is equal to, the length of the rectangle is equal to 2x plus 3, which is equal to 2 by, what is your x? 8.5. So it's 2 by 8.5 plus 3. You find it. Then you can say the width is equal to x plus 1, okay, which is equal to 8.5 plus 1, which is 9.5 centimeters. What is 2 by 8.5 plus 3? What do you get? Something centimeters. Now you say perimeter will be equal to 2 lengths plus 2 widths. This is perimeter, distance right round. Length, width. So 2 lengths plus 2 widths. So which is going to be 2 widths is 2 by 9.5. Then what is 2 lengths? It's 2 of what? Can somebody punch for me? This one is for, this is the last one. Lusika. What is the length? Punch this for me, please. Two by 8.5 plus 3. What do you get? Lusika, what do you get? Lusika, are you around? Lusika? Letty, can you tell me what you get here? Two by 8, 2 open bracket 8.5, then say plus 3. What do you get, Letty? Yes, you get 20. Well done. Now, tell me what you're going to get for this lesson. Kingsley, I'm back to you. Tell me what we get here. 2 by 20 plus 2 by 9.5. What are we getting? Kingsley, what are we getting here? Well done. 59 is the correct answer. So, what did you learn? Mr. Clarify taught you something which is going to be very useful for you when you do A-level maths. It is that always use the answer you are given, even if you fail to get it. If you fail to get 8.5, still it is the one to be used here because they say show that. So they know Cambridge won't make a mistake. They've tried it over and over and proved it. So they know that X is supposed to be 8.5. That's the one you're supposed to use in the second part. Make sure you use it. Don't use your value. Let's say you got 10. You should still use 8.5 in part B when you are replacing X so that you find your lengths and your widths for the perimeter. All right. Yeah, we were doing sectors today with the juniors. Go watch on the live. If you go to live videos, right? And you see, you search Mr. Clarify on YouTube. You go to live videos. You go, you see where it says IGCSE maths, where I did a lesson before you guys. And I was doing the sector questions. I want you to just go and check and see how you can solve this one. It's very helpful. So, let me just do it. For a sector, there are 3 formulas only that you use. So it's the formulas are area of a sector is r squared theta over 2. So if you get a piece of pizza in the exam, you're going to start smiling because you know what to do. Then there is S, which is this distance outside here. And this is the S. It's the arc, okay, or arc length. This is r theta. And then there's the final one, which is perimeter of the sector. What you must know is that these two are both R's. They're always the radii. They're always the radiuses. So it will be perimeter is 2R plus S. This will be the perimeter of the sector. Now, you have these three formulas. So when you get this, you must write them down. Before you do anything, you must write them down. Then step number 2, what you always do. So step number 1 is to write down all the formulas. Step number 2, when you are now solving and you are given the angle, convert it to radians. Okay? Convert it to radians. So when you want theta in radians, that's the first step before we apply our three formulas. So we just write our formulas down. Okay? Which means we know them. We are showing that we know them. We write down with a pencil. I'm going to use one of you guys. You're telling the formulas to say, hey guys, I'm going to use one of you guys. Now, what you then say is theta is your theta in degrees divided by 180 degrees, so that we remove degrees. We divide by 180, then we multiply by pi rad. Okay, we have changed simple like that. So we're going to say theta in rad. That's the very first step now. What you write on the thing you are taking to Cambridge. Theta in rad. It is going to be, what is our angle? 50 degrees. You divide it by 180 degrees. Then you multiply by pi rad. Okay, pi rad. Multiply by pi rad. And don't make it a decimal. Leave it as a fraction. So here, 0 and 0 will cancel. You cannot reduce 5 over 18. It's already in its thing. So this is, by the way, when you cancel, you can cancel softly with the pencil so that we can see what you had written. So you can now say 5 pi over 18 rad. This is your theta. That's good. When you are actually doing the calculations, always make sure your angle is in rad. Now we can answer any question. Let's see what we are going to use here. They say the shaded segment has area. So this is why you guys are writing this here. This is harder than what it would be for IG. They're saying the shaded segment has this area. So now you have to now write area of the shaded segment, because they have said this. The shaded segment has this area. That means we have to write that down. So how do we get area of this thing here? How do we get area of this? We are never given. We are never given. But you are not going to let me down. A segment is not any shape. It is nothing. There is no day when Mr. Clarify came and gave you formula of a segment. But what Mr. Clarify gave you is the 3 ways to get area of a triangle. So we can get area of this triangle. And we can subtract it from the area of the sector itself, which is in pink. So we get the whole sector in pink. We remove the triangle, which is this. Area is the inside, right? So we remove this. Obviously, we will remain with the segment. So we will say area of segment. There is no area of a segment. To get it, you say area of sector minus area of triangle, which is going to be, what is the area of the sector? R squared theta over 2 minus, what is the area of this triangle? Let me ask somebody who should remember. This triangle, Kelly, what is the formula of the area of this triangle? We did 3 triangles. Which one is this one? How do you get this area, Kelly? Kelly, is this one base times height over 2? Kelly, are you there? Kelly? Laura, are you there? Laura, Kalalelo. Okay, Sarah. Yes, well done. I see your hand is up. Sarah, which triangle is this one? Yes. Good. And are we given the base and the height? No. Mm-hmm. So which formula do we use, Sarah? Yes, or we can say AB sine C over 2. I like to say over 2 so that people know that the half is just the same as saying divided by 2. I gave you the three triangles, students. This one, which is a right angle triangle where you have the base and height, and I say area is base times height over 2. This is the triangle number 1. Okay? Triangle number 2 is this one with no right angle at all, just like this one. But I said in here they'll be nice to you. They'll actually give you the height and put a right angle to show you this is the true height. Then this is the base. Okay? They won't tell you it's the base. So you should know that area in this case will be base times height over 2. And I say the third situation is when you're given this side, theta, and this side. So you will now say area is A, which is this side, times B, which is the other side, times sine theta divided by 2. Are we together? Students, are we together? So this is your opportunity to shine. You will see that this is situation number 3. So you'd say, okay, so it is, what is the A? The A is R. What is the B? The other side, it is R. Times sine theta, which is sine 50. So it will be R by sine 50 degrees. You say, no, say, wait a minute. Why are you using degrees? We changed to rad. No, when you have a sine, you can keep it, okay? But when you have a theta without a sine, that's when you have to put this one. Here it's sine 50. So then you say over 2, okay? AB sine 50 over 2. So you multiply this side times this side times sine of the angle divided by 2. I will be so happy if you can do this. It's your opportunity to shine. So you now say area of the segment will be equal to, what is your R? They say show that R is 23.7. Okay, fine. They say the area of the shaded segment is 30. So instead of area of shaded segment, you can now say 30 is equal to R squared by theta. What is theta? 5 pi over 18. And this is all divided by 2 minus, this is R times R, which is another R squared, times, what is sine 50? Is it a good answer? Is sine 50 degrees a good answer? You say divided by 2. Okay. So here's a trick. We'll start doing. Since you have a 2 and a 2 on both of them, you can bring it out. So you can say 30 is equal to 1 over 2. The 2 is out. You now get R squared by 5 pi over 18 minus R squared by sine 50 degrees. Okay, we brought the 2 outside. When you divide by 2, it's like a half. The only time you can bring it outside if it's if it's there on both. Now you can take this half to the other side. It will go to multiply. So it'll be 2 by 30. This is equal to 5 pi r squared over 18 minus sine 50 degrees r squared. This is 60 is equal to, here all we have to do is to find r. Okay, so we are doing r, make r the subject. It's a bit of maths. It's a bit of maths. Let me make it spaced out so that I have more space to work it out. We are doing well. We are almost getting the answer. So this is actually now just subject of the formula. We have to be careful. 60 is equal to this. 5 pi r squared over 18 minus sine 50 degrees r squared. So say, what did you do? I just took half to the other side. I factored it out because it was there on everything. Then I took it to the other side. It multiplied. Now, what is sine 50 degrees? What is sine 50 degrees? Oh, it's okay. It's not really a good answer. So look at what we're going to do now. Everybody, look at what we do. We multiply by 18. Everything by 18. Okay? We multiply everything by 18 so that it becomes 60 by 18, because we don't want any fractions, is equal to 5 pi r squared over 18 by 18 minus sine, you can say minus 18, or you can say minus sine 50 degrees r squared by 18. 18 and 18 will cancel. We will no longer have a fraction. What is 60 by 18? What is 60 by 18? I want you guys to be punching. Eric, what is 60 by 18? Oh, hi, Ayanda. How have you been? Okay, I saw your timetable yesterday. We'll talk about it. And Lusika, I saw yours. I'll get time to go through it tonight. What is 60 by 18? 1080. This is equal to 5 pi r squared minus whatever. Here you can say now 18 times sine 50 of r squared. So you say 18 sine 50. You get 13.78. So minus 13.78 r squared. So now you have things with r squared. So punch now, everybody. Say, if you want, even before you do it, even if you say it is minus 18 sine 50 degrees of r squared, it's still fine. Because what you do is you bring out the r squared. We need r squared, class. We need r squared to be alone. So you bring out the r squared now. You say 1080 is equal to r squared comes out. You remain with 5 pi minus 18 sine 50 degrees. Okay, if r squared comes out. Because there is r squared here and there is r squared here. So you bring it out. Excuse me. Which makes you take them to the other side. You say 1080 over, because the r squared was multiplying now to the, so you take this to the other side. It will divide 5 pi minus 18 sine 50 degrees. This is equal to r squared. Whoa. If you do perfect maths like this, wow, I'll be so excited. Just go step by step, doing subject of the formula. You now take power of 2 to the other side. It becomes a big square root. You know that when it goes to the other side, it becomes a big square root, and r will remain alone. Square root of everything that was there, 1080 over 5 pi minus 18 sine 50 degrees. What do you get? I've showed you how to punch it. If you punch it, say square root. Then you say open bracket. Since there's one thing at the top, we don't need to put it in bracket. Say 1080 divided by, then you open your bracket. You say 5 pi minus 18 sine 50, close. Then close the bracket for everything in here. Say is equal to. You must get 23.7. Antonisha, punch this. Excuse me. This is the last one, yeah? It's the same paper, by the way. We were just doing one paper. One paper for it's the one that had all these questions. Antonisha, what's the answer? You got 7.41. Let me help you. Okay. Good. 23.7. This becomes your R. Good. Now, even if you don't get it, this is the last time I'm showing you. For when they say show, that means this is the answer. So if you want to continue to the next region, to the next question, you use the same answer you just found. Because now they'll say, what is the perimeter of the shaded segment? Perimeter of the shaded segment just means, hey, find the distance right around it. Find this length. You have found the R, which you know, they told you is 23.7. So the only thing we now have is we know that this is 23.7. Now, we know that this is arc, which is S, and we know how to find it from here. It's R theta. So here we have the R theta. Then, so it's 23.7 by theta, which is by 50, not 50 degrees. You use this one, the radians. So you can say, if you want perimeter, you first get S. S is R theta, which is 23.7. You use their answer, even if you didn't find 23.7. Use their answer, it's the correct one. By theta, which is by 5 pi over 18. I will be so happy. What makes me happy is people know formulas. You know the formulas for sector. And you are doing hard questions step by step. That would be very, very good. Very, very good. So now you'd say 23.7 by this. So somebody please do it. 23.7 times 5 times pi all over 18. Okay? Since there's more than one thing in the numerator, you put it in a bracket. Open bracket 23.7 times 5 times 5. Then divided by 18. What is the answer? For S. Then now we just have to find this last side. This last one. And let me see the mark so that I tell you. So, this is trig, okay? This is trig, which I'll tell you just right now as the last thing. If you have an angle that is sitting inside two sides that you know. So triangles are easy. If we struggle with triangles, then there's something wrong with us, because triangles are easy. So this side, we know its radius is 23.7. We put it. This side, we know its radius. We don't need anyone to tell us, because it's a sector. It's made by two radii. So it's 23.7 and 23.7. And this angle is sitting inside, it's hiding. Whenever you have a situation like this, two sides that you know, and an angle sitting inside of them, to find the third side, you use the cosine rule, because the cosine rule works in this situation. This type of angle is called included angle. Included angle is an angle that sits inside two sides that you know. I know this side, I know this side, and I also know the angle. So this is called included angle. I know this side, I know the other side, I also know the angle. To get the other side, I use the cosine rule. What we'll just say is, let's say we want to find this here. It's AB, or its opposite big O, so it's side small o. This other one, opposite big A, it's side small a. Even if you want, you can just call it AB. Let's call it side AB so that I don't increase the work for you guys. So cosine rule, you write it like this: AB squared, which is the third side, the side you want, which is opposite this beautiful situation. We have this beautiful situation, the included angle. Great situation. We know this side, we know this side, we know the angle that sits between them. So this is called included angle. So what we are doing now is we are looking for the opposite one, which is AB. We make it squared, and we make it be equal to the other two sides squared as well, like Pythagoras theorem. Okay, the other two sides squared, and they should be adding. Okay, so it will be 23.7 squared plus the other one. In this case they are equal, but in some cases they are not. 23.7 squared as well. Then where it becomes different from Pythagoras theorem is you now say minus. Okay, after putting it, you now say minus. Then you put a 2. Then you bring the two sides again, but this time they should not be squared. So you bring them again, 23.7 by 23.7. And you now say by cos of this angle, cos 50 degrees. This is the cosine rule. You punch it, you get an answer, you're done. This should be alone, by the way. So punch it, let's see. The same way you see me having done it. Punch this, let's see. To get AB squared. The other missing side. So I'm teaching you triangles. I didn't really teach you everything. I'll do a lesson on triangles, one of the next lessons. First, we should keep doing this situation. Hi, Wesley. Okay, yeah, all good. Let me wrap up. Okay. So, what is the answer? Punch it this same way. One dipper. What's the answer here? This bracket which I've put as square in your calculator is the normal one, this one. This is a minus. What do you get? Is it something you can punch? One dipper? Yes. Who has punched it? Sarah, did you punch this? What's the answer, Sarah? Who has punched it? Students? Somebody punch? Who has punched it with me? Can you guys hear me? Majita, can you hear me? Majita? Okay. After you put your minus, remember to open the bracket. Then you open bracket, then you say 2, you open another bracket, you say 23.7, you close, you open again, you say 23.7 again, you close, then you say cos 50 degrees, then you close. What do you get? For AB squared, you must get 401.285. Then for AB, it is the square root of that, or 401.285. Okay. And you get AB as 20.032. So this is where the 4 marks was coming from, because now for this other one, which we didn't do, it was 23.7 times 5 times pi, and divided by 18, which was 8.27, which meant that perimeter now is equal to this S by AB. This is AB. So you just do, that's the whole distance. You do S, then you do AB. So it is equal to S plus AB, which is okay. You should get 28.30. This is your final answer. Whew. This paper was, yeah, something else. A lot of questions on mensuration, so it took us a bit of time. But it's fine. It was good practice. Took us a bit of time. Sorry for that. Anyone with a question on this? Anyone with a question? No question?